Welcome. This is Altemmen reporting live from our 4 meter below sea level studio in downtown Almere. Today we were at the second day of the TSMC 2020 event. So yesterday there was a technology symposium. Today was the Open Innovation Platform Ecosystem Forum, which was focused around the partners. The TSMC event is all around the world, but here in Europe there's a special part especially assigned and addressed to the people in Europe, and also having our time zone, which makes it easier to follow. The Open Innovation Platform Ecosystem Forum started this morning. This was 10 minutes before start, and it was opened by Maria Marcet. Maria Marcet is the president of TSMC Europe, and she gave a short introduction about the day and also about the event. And she also recalled that yesterday there was a keynote by CCY. By the way, we also have a report about yesterday, so you can see that on our channel too. So this was the keynote, and she also then introduced the speakers of today. So apart from the keynote speaker, which will follow after her presentation, there will be 3 people from partners. And we also will shortly discuss those 3. Then there were also 21 papers selected. So these were technical papers, and we will just have a look at one of those. So this was the real technical stuff. After her introduction, it was time for Cliff Howe, who is a vice president, senior vice president, to talk a little bit about the developments in TSMC, and especially around the platforms. So they have special custom and optimized design enablement platforms for different kinds of industries and different kinds of technologies. And there's one which is especially for high performance computing, and there it's aimed at sustainable performance, memory bandwidth and reliability. He also showed a little bit more detail for each of those platforms, and this one is for the TSMC high density library, and it shows basically that the improvements that you get from getting from 7 nanometers to 5 nanometers to 3 nanometers. For the high performance library, that means, for instance, that you can also make choices. So for instance, you can choose, if you go from say 7 nanometer to 5 nanometer, you can have improvements in performance, or you can have a decrease of the total power used. So there's some flexibility. He also explained in detail what the status is from each of the technologies. So the 5 nanometer technology, the foundation library is ready. You can see that in blue for high performance computing. That's this column. So you can see that the foundation library is blue, is okay. Non-volatile memory is okay. They're still working on interface IP, which is almost also good. And these are the companies that they are working with. So it's not like TSMC does it all on their own. These are the partner companies. And Synopsys and Cadence are mentioned here, and they will be back in the next presentations. So in a summary, the new developments, so that will be the 3 nanometers in a few years' time, will be aimed at both smartphones but also be used in HPC applications. The 5, 6 and 7 nanometer designs are real production chips, and you can use them now, and they are used by people now. So that was the keynote. Then we went to the first presentation. So actually there were 3 presentations. You could choose which one to do first. So we took this one from Aart de Geus from Synopsys. Actually, Aart de Geus was born in the Netherlands, but then he moved after a few years together with his parents all around Europe. But you can see that he still has some Dutch roots, because this is a picture from Escher, where two hands are drawing each other. So the green hand is drawing the blue hand, and the blue hand is drawing the green hand. There's a chip in the middle, and I don't recall that Escher did actually paint that. Anyway, so for the Geus, that means that the one hand is Synopsys and the other is TSMC, and they really work closely together. And actually he said, well, oh yeah, by the way, he also gave the presentation more or less in a way that I do it, so standing in front of a window and having his slides there. So actually I'm a bit superfluous here. It would be better if he was just presenting himself. But anyway, I'm just doing the highlights, so the whole presentation lasted about 20 minutes, but it's really worthwhile to see. So anyway, Synopsys and TSMC, they're working together, but it's not only the sum. Actually, it's more the product, he said. So trust and teamwork is the things that they really bound together and make innovation happen. Then he was diving a little bit deep into the things like function, form, and physics, because that are the three things that come together in chips and how that work together. So he went back a century ago, 1.5 centuries ago, I think, when Louis Sullivan said, well, forms need to follow function. So you need to know the function, and then you can adapt the form to that. About 50 years later, Frank Lloyd Wright said, yeah, no, there should be one actually. And the Geus says, well, actually there's three things which are important. So the function, the form, and the physics, and they should come together in the good way. He also then said that, well, if you look at the function and the physics, then you can actually make it a little bit elastic, and then the form doesn't really have to follow the other two, and that means that you can get beyond Moore's law. In TSMC terms, that is, you get more than more. And that happens because in this part you get 2D and 3D packaging, which stacks things together in the chips. A complete different topic that he discussed was how do you make all these designs? There's a big design space, so it's not the real space, it's the design space. And in the design space you have to look for the minima in performance and in costs and power, etc. Of course, normally the engineers do that themselves, and they think, well, this fits, and then they do calculations and models. But you can also use machine learning to do that. And if you do that cloud-based, then you can even do it very fast. So then in machine learning, you can find the optimal minima and the optimal design points. That was a few of the highlights from Aart, Geus and Synopsys. The second presentation that I did watch was from Mr. Tan, Lip-Bu Tan. He's from Cadence Design Systems, and he was presenting from home, so like a lot of people do these days, presenting from his house. He started with explaining that the most important thing which drives the silicon developments currently is data. So data analysis, data transmission, data processing, and data storage. What does Cadence do? So Cadence typically works together with IP companies like ARM and with the companies that make the hardware like TSMC. And Cadence does the integrated circuits, the packaging, the board design, and interface IP. That are the things. But basically, it's also working together with the other ones. He also showed a little bit about 2.5D and 3D packaging, and the newest kid on the block is chiplets. So chiplets are on vogue these days, and they're a very nice way of packaging and putting complex chips together. This is the one of the, let's say, 2.5D stacking. So you have here the substrate, and then you have different wafers or different parts of the chip, you could say, and they are very closely connected already in the factory. And that are the things that they say can lead to more than more. If you want to design your chips, you need to emulate them, and Cadence provides the software and tools for that. You can run them on your own systems, or you can use the Cadence Cloud, which works together with others, to do that. And then you can, through the Cadence Cloud, access systems or virtual machines on which you can use the emulation software. So you have emulation capacity when you need it. That was Cadence. Then a third presentation was from Mentor. And that was presented by Joseph Sawicki. And as you can see, he has the same barber as I have. Very nice looking. He was also presenting standing around, and I think in front of a park or a garden, probably the park, I don't know, probably the park from close to Mentor. And he was discussing, for a start, he was also saying, well, you know, there's more to more than more. Illustrating that with this slide from TSMC, which was from the Hot Chips 2019 conference. So you have probably seen, or you still can visit, our reports from the Hot Chips 2020 conference, which took place a few days ago, and the reports we made are still online, so see it on our channel. For more than more, what Mentor is doing is they do verification of chips and validation of chips. So that means that if you have a design, you want to know, does it work? Well, you need to verify that, and you need to validate that it works according to the design before you really put it in hardware. And that's where the Mentor software like Calibre comes in. He also introduced a new piece of their validation verification software called Tenor, which also works for silicon photonics. And for this, they are also partnering together with TSMC. And also for accelerating the verification, they also work very closely, and that means that sometimes they can even reach 30 times improvements. So he also stressed the importance of partnering between Mentor and TSMC, working together with each of the two having their own expertise. So the focus, what they have, is reliability. So within the ecosystem, so the Open Innovation Platform ecosystem, Open Innovation Platform is the term that's coined by TSMC for the partners working together. So in that ecosystem, Mentor looks especially at reliability. That's what they bring onto the table. For instance, they also mentioned collaboration with another partner, which is Graphcore, and Graphcore has 2.3 billion transistors. It's one of the most complex AI chips around. And it took them about 3 days just to bring the test up. So without testing from Mentor, it would be impossible to design this type of complex chips. Does it help to be part of the Open Innovation Platform? Yes, he said, of course. Because if you look at the developments, 2013, there was technology around 28 nanometers. Now it's 7 nanometers. there are now 8.5 billion transistors on a chip, and 2013 there were only 1 billion. The CPU performance is about 5-fold increase, and the GPU performance about 10-fold increase, which is only possible because these partners and TSMC are working together. That was Mentor, and that was also the third of the 3 keynotes by partners. As said, there were also presentations which were much more technical of nature, 21, and we just picked out one. That's the one from SiPearl, which they did together with ARM. So there was a combined presentation from ARM and SiPearl. Well, we picked this out because SiPearl is developing the HPC processor, which should go into the Euro HPC supercomputers. It should be an important part of the ecosystem. So, and SiPearl is working together with European Processor Initiative, as you know. One interesting word on what they said is that they create a high-performance processor, which is fine, but here they mention hyperscale computing, and I think this is the first time that they really mention hyperscale computing, because before it was high-performance computing, automotive computing, edge computing, but not hyperscale computing as a very important item. I don't know whether that was on purpose. So how does it work, the SiPearl? There has been a paper which has recently been published, and you can still find that on the internet, which goes very much into detail of the design, and it's very useful to read that paper too. But if you can access this presentation, of course you can just follow this presentation. The SiPearl platform works with the Zeus. The ARM Zeus CPU as compute unit, as a building block, and then it adds high bandwidth memory and other memory, and it connects the whole stuff with the PCIe, and it should be a little bit low power so that it can build large systems. SiPearl is building a common platform, which means that they will have parts which they develop themselves, but also others can put in parts of their own using the chiplet technology, but also it means that they can have versions of their platform chip which can be targeted towards HPC, and other ones can be targeted towards automotive. They work together with ARM and with TSMC, and with ARM because of the IP, the basic IP, and because of the development environment, and TSMC because of the silicon process that they have and the 2.5 dimension integration. What they use, and this was a part then that was presented by ARM, is the ARM Neoverse IP product platform. So that's the basis development platform that SiPearl then uses, and that was further explained by ARM in this presentation. So that will bring them together to a solution which will be very versatile and which is rather flexible and has a kind of hierarchical implementation. So that's the SiPearl design. And that was also the last presentation that we wanted to show to you. Which means that it brings to the end our reporting for the second day of the TSMC event. So actually it was 2 days of very intense and very interesting presentations with today again several highlights. We hoped you enjoyed our coverage, and if you do, please like us on our channel, and also please have a look at the other coverage that we have of yesterday's presentations, but also of the other related conferences like the Hot Chips conferences. So for Primeur Magazine, this was Art Temmen reporting from 4 meters below sea level in our downtown Almere studio. Until next time.